All right, so 5.4, getting into the big boy math here. Factor and solve polynomial equations. How can you solve a higher degree polynomial equation? So you have to remember that factoring completely, a factorable polynomial with integer coefficients is factored completely if it's written as a product of unfactorable polynomials with integer coefficients. That means whatever you're left with can't be factored anymore. Factor by grouping was a way that you probably learned already. You should have learned already. It's to factor a polynomial with 4 terms by grouping. Factor common monomials from pairs of terms and then look for a common binomial factor, and we'll kind of look at that later. So take just a minute to do the warm-up. There's the answers in a cool, funky orange neon color. Even though it's kind of cool, I'm not sure it's the best one to use for the video. But take a look at that. Remember that here you have the sum and difference, which was one of the special patterns we learned in the previous lesson. This is the square of a binomial. Also one of the special patterns. It's kind of good to get comfortable with that multiplication, because you're going to see some more of it today. All right, so let's move on. The first thing I wanted you to do is look at page 353 in your book briefly. What helps you with terminology here, this little table is a general trinomial. If it was just a general trinomial, you have learned how to factor into 2 binomials. Perfect square trinomial, we looked at that just in the previous lesson. Difference of 2 squares factors just to those 2 binomials. And you always, always, always should look for a common monomial factor that you can pull out of each term. So that's just a little refresher there. So let's do a little bit of practice with this. This is that when you should always look, before you even start factoring, no matter what, you should always look to see if you can pull out a common term from each monomial. Always check first if you can factor out a common monomial from each term. So if I look at this, I'm going to look at each term and notice that there's a, well, first of all, let's look at the coefficients. There isn't a common coefficient that I can divide out of each term. But if I look at each term, there is at least one y in each term, so I'm going to divide out a y from each of them. And it's kind of like the distributing in reverse, sort of, distributing in reverse. So you're pulling out a y, and when you divide this term by a y, you have y squared left. When you divide this term by a y, you have negative 4y left, and when you divide this term by y, you're left with just 12. Then you should always check if you can go further. Can you factor this further? That's what factor completely means. Go all the way down till you can't go any further. So the y is a factor, and I'm going to look at, this is a trinomial with a is 1, so I can just look at the end term, negative 12, and say, are there factors of negative 12 that add to negative 4? Yes, negative 6, and 2. So this can be factored into 2 binomials with these negative 6 and 2. And then you've done it. You've gone as far as you can go. So let's do another one of those. Look at each of these terms. Look at the coefficients here. I can see that I can divide out a 3 from each of the coefficients, and I have an x in common in each term, so I can at least pull out a 3x from each term. So I'm going to pull that out front, like undistributing. For this one I have left x squared. This one I have 30 divided by 3 is 10. X squared divided by x is just x. This one, 75 divided by 3 is 25. X divided by x is 1, and they cancel each other out. Then I decide, wait a minute, I think this is a perfect square trinomial. So I know it is, so I can write that like this, x plus 5 squared. Then you've factored it completely. So this is actually 3x times x plus 5 times x plus 5. All right, one more. 5 and 80. 80 can be divided by 5, so I know I can pull out 5. And then the most number of g's that I can pull out from each term is 3. I can pull out a g cubed from here and a g cubed from that term. So I'm going to pull out a 5g cubed from each term. This will leave me with g squared minus 80 divided by 5 is 16. G cubed divided by g cubed cancel each other out. Then I have to say, wait a minute, can this go further? And yes, it can. It is a square of a binomial, so it's going to look like this, 5g cubed. I know I'm going to have two binomials because I don't have a middle term, so that means I had to have g plus 4 and g minus 4. So now it's factored completely. Okay, so previous lesson we had sum and difference of squares. Now we have a sum of two cubes and a difference of two cubes. And I would say, yes, you probably should memorize this pattern. It'll make your life a lot easier. So look at this. If we can end up with a cubed and b cubed, then we know that that can be factored into this. And a cubed minus b cubed. So first of all, sometimes you don't always know if a number is a perfect cube. So let me show you how you can at least take the cube root on the calculator if you're not sure. So let's say you have the number 64 and you want to know if it's a perfect cube, which it turns out it is. What I'm going to do is I'm going to actually go to the math button right here, and if you go down to number 4 you can see it says cubed root right there. It's a little square root sign with the 3. So I'm going to push that, then 64, and it turns out that the cube root of 64 is 4, so that means a perfect cube. So if you're not sure and you need to test it out a little bit, that's how you can do it. Alright, so I've been told I have to factor this. First of all, see if you can divide anything out. You can't. Second of all, sometimes I look to see, okay, this is a perfect cube, this is a perfect cube. So I'm going to rewrite it so it looks like this. So the cube root of 27 is 3, cube root of x is 3x, and I'm going to write it like that. Plus, cube root of 25 is 5. So I'm going to write it like that. I just rewrote it. Now I know that this, hold on a second, this is A and this is B. So I can now use this special pattern to write out the factors of this polynomial. So I know the first part of it is going to be just A plus B. My A is 3x, my B is 5. So that's one of the factors. Again, I'm just following this pattern right here. Then it tells me I'm going to multiply that by A squared. 3x is A times 3x is 9x squared. And then I'm going to minus it by A times B. Let me get that brightness back again. Hold on a second. I'm going to minus it by A times B, so that'd be 3x times 5, which is 15x. And then I got to add to it the square of b. Oh, I want to write b squared. No, I don't want to. I want to write plus 25. Now, you might look at that and say, can it be factored? And you might play around with a little bit with it, but it turns out it can't be factored anymore, so that's as far as you can go with that one. Okay, let's try another one using this special factors patterns. But first of all, don't forget, anytime you start to factor, you've got to decide, can I pull something out of both terms? And yes, I can here. They can both be divided by -2, and I can take a d squared out of both of them. So I'm going to do that. Divide by -2d squared. And pull that out front. That becomes one of my factors. This then, I'm left with d cubed minus 125. And then, oh, would you look at that? This is a cube, and this is a perfect cube. So, if I rewrite it, it would look like this. D cubed, that becomes my A. And the cube root of 125 is 5 cubed. That becomes my B. So I can just follow, for this particular factor right here, I can follow this special pattern. So I'm going to bring along -2d squared for the ride, because it is a factor. And I'm going to follow this pattern here. I'm going to do A minus B, so it's D minus 5 times a squared, which would be d squared, plus a times b, which would be 5d, and then plus b squared, which would be 25. And then I have all my factors using these special patterns. These are pretty handy. All right? All right, let's do some more. Flip it over. Now, part of what you're going to be doing in this section is factoring a polynomial completely. And you have to kind of decide which method works best, grouping, box method, whatever. Let's review grouping. When you have, as it says here, a polynomial with 4 terms, you can factor it by grouping. Sometimes that's the easiest way to do it. So always, always, always look to see if I can factor something out of each term, which I can't for this one. So I'm going to just try grouping, since I have 4 terms. And what you do is you group the terms into two binomials. And then you look at each binomial separately and say, oh, well, look at this one. I can divide something out of each of those. I can divide out a 9t squared. So I'm going to do that from each of these terms. I'm going to pull that out front and simplify what I have left. I have a 3t left plus 5. Now, what you get here kind of tells you what you have to have left in here. Right now I have a negative 3t minus 5. I need it to be 3t plus 5, so I've got to divide out a negative 1. So that's going to be coming right there, minus 1, and then I'm left with 3t plus 5. And when these match, then you can finish up the problem. So now what you do is you have 9t squared times 3t plus 5 and minus 1 times 3t plus 5. And you can rewrite it like this, 9t squared minus 1, I brought that and that together, times 3t plus 5. That's grouping. Hopefully you've seen that before. Oh, but wait a minute. This can go even further. This is a perfect square trinomial, so I can split that up to 3t minus 1, 3t plus 1, times 3t plus 5. Oh, that is a lot of fun right there. All right, let's do a couple more. So this one here is also going to be a grouping. I don't think I'm going to finish it. You just group it like this. See what you can pull out of each term, just like that. And see what you can pull out of here, which would be a negative 9. And just so you know, this is what you end up with. Just because the video is going to get too long if I do the whole thing. This again can be factored to x plus 3 and x minus 3 times x plus 7. And then these are your factors. Let's look at this one, because you might see some like this. First of all, always say, can I divide something out? Yes, I can. This does not have 4 terms, so I'm not going to group. I'm going to try a different method. First, I know I'm going to do this. Divide out a 10, and I have x fourth minus 1. You can treat an even binomial or an even exponent and still use the special patterns. Okay, it's a square of a binomial. So I know that, or I think I know that I can do this. And if you don't trust yourself, FOIL these two and see if you end up with that. But you do. No middle term, so I know I got to have a minus and a plus here. X squared times x squared is x to the 4th. Negative 1 times positive 1 is minus 1. So I know I can do that. And I know that I can take this one step further because it's the same kind of instance. So it's going to be 10 times x minus 1 times x plus 1 times x plus 1. Look at that. Or excuse me, x squared plus 1. And that's as far as you can go. Those are all the factors of 10 to the 4th minus 10. Okay, this one here. Let's look. I can't divide anything out. I don't have 4 terms, so I can't group. So then I would probably try to do the box method, or whatever the method you might want to use. So I'm going to set this up like this. 2d to the 4th here, negative 45 here. Since this is not 1, I got to multiply 2 times negative 45. 2 times negative 45 equals negative 90. And this is going to help me find what goes in these boxes. What sum will give me negative 13. So I need factors of negative 90 that will add to negative 13, my middle term. And I just happen to know that it's negative 18 and 5. And how do you find those factors? You just play with it a little bit on your calculator. So you put these numbers in these boxes. It doesn't matter where. I'm going to put negative 18 here and 5 here. Then I look across this row and say what's a common monomial I can pull out of both of them. I can pull out a 2d squared. Once you have one of those, you kind of go around the box then. And you look at this first box here. What times 2d squared will give me 2d to the 4th? That's d squared. This would be negative 9. D squared times 5 would give me this box. And then just check to make sure 5 times negative 9 gives me negative 45. Now I have my factors. And I'm just going to make sure that 9 and 1 of them can be factored further. And this one can. It's a perfect square. So it's 2d squared plus 5 times d minus 3 times d plus 3. And then you've factored that completely. Okay, there's a couple other things you're going to see. It says find the real number solutions of the equations. What that means is you have to set whatever you're working with equal to 0 and solve for x, not just factor. Okay, so I'm not going to do both of them because it's going to take a little too long, but I'm going to help you get this one set up. First of all, it's not set equal to 0. So I'm going to subtract this from this side. 48p to the 5th minus 27p cubed equals 0. And then I'm going to divide out what I can, which is 3p cubed. Pull that out. I'm left with 16p squared minus 9 equals 0. This is a perfect square trinomial, so you would just keep going, and then you'd set your factors equal to 0, and you would get p equals 0, p equals 3/4, and p equals negative 3/4. So I know I went through that pretty fast. I didn't really finish it, but I want to do a little bit more on this one. Okay, so again, you have to solve for t. Always, 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 always look first to see if you can divide something out of each of these terms. And I can. I can pull out a 4, and I can pull out a t squared from each term. So I'm going to write that out here, 4t squared. I think sometimes it's easier to write it underneath each one to help you see what you're going to end up with. So here I'm going to end up with a t to the 4th left, minus 5t squared, plus 6 equals 0. Okay, I have this factor and this factor, but I think this one can go further. It's not 4 terms, so I can't group, but maybe I can do the box method, just like I did above. So I'm going to try that for this right here. T to the 4th here, 6 here. Since this is a 1 right here, I don't need to really worry about that. What I do need to do is find factors of 6 that add to negative 5. Factors of 6 that add to negative 5, and that would be negative 2 and negative 3. So that's going to go in these boxes here. Negative 2, t squared, negative 3, t squared. Then I see what I can divide out of each of the first row, and I can pull out a t squared. Once I have that, I just kind of go around the box. T squared times t squared gives me t to the 4th. And I'm going to have negative 2 here, because negative 2 times t squared gives me that box. This would be negative 3. And negative 3 times negative 2 gives me 6. So I'm good. So I have my factors. Let's not forget about 4t squared. That is a factor. And I'm going to write these down. T squared minus 2. T squared minus 3, set equal to 0. Okay, I've got to set each of these equal to 0 and solve for t. So 4t squared equal to 0. If I solve that, it'll give me t equals 0. There's one of my solutions. T squared minus 2 equals 0. Add 2 to both sides. I get t squared equals 2. Take the square root of both sides, and I'm going to get t as being plus or minus the square root of 2. T squared minus 3 equals 0. Add 3 to both sides. T squared equals 3. And when I solve for t, I'll get plus or minus square root of 3. Here's my solutions. This is where this polynomial of degree 6 crosses the x-axis. They're all real solutions. So let me just show you what it looks like, just because it's kind of nifty. I did graph it. Let me find it so you can see it. There's my y equals, and there's the graph. You can see there's plus or minus square root of 2, plus or minus square root of 3, and 0. Isn't that's pretty nifty. All right.